Hi everyone, my name is Malay Kumar. Today I am going to talk about the randomly exploding random tree. Here is the table of content. In this, I am going to cover about the basic of path planning, types of path planning algorithm. The first one is search-based planning. The next one is sample-based planning. I cover about the randomly exploding random tree basics, then the RRT algorithm, then the application and the references. What is path planning? Path planning is a fundamental problem in robotics which involves finding a collision-free path for a robot to move from an initial position to a desired goal position. Path planning algorithms are used by mobile robots, unnamed aerial vehicles, and autonomous cars in order to identify safe, efficient, collision-free, and least cost travel path from an origin to a destination. Path planning algorithm helps to ensure safe and effective point-to-point navigation. Next one is types of path planning algorithm. Basically, there are types of path planning algorithm. Path planning algorithm is basically used for finding the path from one location to another location. In any robotics path planning problem, the most common problem, given a start point and a goal point, we have to find a path between the start and the goal, such that we do not collide in any of the obstacles. You have the map of the environment, you know where you are and where you want to go, and you want to find the path between the start and the goal. There are two major types of path planning algorithm. First one is search based planning, the second one is sample based planning. In the upcoming slide, we are going to talk about these types of path planning algorithm in details. The first one is search-based planning. Search-based planning creates a searchable graph with each vehicle state or configuration identified as a node. The graph expands from the start to the goal node using cost and heuristic-based approaches to find the shortest path. Heuristic is nothing but it's a function that provides an estimate of the minimum cost between a given node and a target node. Heuristic function is basically used to help the algorithm to minimize the search area of the search-based planning is commonly preferred on a decentralized map where the map is subdivided into a grid cells and the number of states is finite or countably infinite. The popular example of search-based planning is A-style algorithm. The A-style algorithm examines all the neighboring nodes and calculates their distance from the starting node and their estimated distance to the target node, often called as the heuristic value. It then chooses the node with the lowest combined cost and add it to the closest list. The algorithm then examines all the neighboring nodes of the choosing nodes and so on until it reaches the target node. Here is the example of the working of the A-star algorithm. In this example, the algorithm first calculates the cost of moving from start node to the next node and add the heuristic. After calculating the heuristic, it will find the minimum among all the neighboring nodes. In this, we can see the possible calculated values are 17, 90, 21, 23, and 25. And we have to select the minimum. The minimum will take us faster to the goal node. So we go along with diagonally and choose the diagonal node. This process repeat until we reach the goal node. The next one is sample-based planning. In sample-based planning, a search tree or a roadmap is created by randomly adding random nodes in the state space. Possible collision-free paths are found using a continuous motion model. Sampling-based planning often use heuristic to explore the search space and bias the search direction. Once created, the tree or roadmap uses the collision-free check or search method to find the shortest path to the goal. The most popular example of sample-based planning is randomly exploring random tree, which is also called as RRT. RRT was developed by Stephen M. Labley and James J. Kuffner Jr. They easily handle problem with obstacle and differential constraints. and have been widely used in autonomous robotic motion. A rapidly exploring random tree is an algorithm designed to efficiently search high-dimensional space by randomly building a space-filling tree. The tree is constructed incrementally from sample drawn randomly from the search space and is inherently biased to grow towards large unsearched area of the problem. Points are randomly generated and connected to the closest available node. Each time a vertex is created, a check must be made that the vertex lies outside of an obstacle. Furthermore, the chaining the vertex to its closest neighbor must also avoid obstacles. The algorithm ends with a node is generated within the goal region or a limit is hit. Here is the algorithm for the RRT. The input of the RRT algorithm is the qint, that is the starting point, and then there are k number of vertices, and the output of the RRT is the RRT graph. Initially, the graph is empty. First, we initialize the graph with the qint, then a loop, then a for loop runs from 1 to k. The qran generates the random point, the nearest q near, calculate the nearest vertex from the random point to all the vertices in the graph. The new configuration takes a new point along in the direction of the random point and nearest vertex at a distance of delta q. If the point is not collided with the obstacle, then we add the new node to the existing node, repeat the process until we reach the goal node. In simple words, this algorithm generates a random point in the sample space, and then a point is taken at a delta q distance along the graph nearest vertex to the generated point and check that if the point collides with the obstacle or not. If it not collide, then it is added to the graph, and if it is collided, then it is not included in the graph, and the process continue until the goal is met. Here, in the previous slide, I have talked about this terminology in the previous slide. Here is the simulation, RRT simulation. In this graph, we can see that there is a starting point, red rectangles identifies the obstacles, green is the destination. The next is application of RRT algorithm. The first one is it is for using robotic path planning. RRT algorithm is commonly used in robotic path planning application to find the path that avoids obstacle in the environment. The algorithm can be used to plan the motion of a robot arm in a manufacturing plant or the motion of a mobile robot in a warehouse. The next application is in the game development. The RRT algorithm can be used in game development to generate random path for non-player characters or enemies. This can make the gameplay more interesting and unpredictable. Next one is autonomous vehicle. RRT algorithm can be used to plan the trajectory of autonomous vehicles. The algorithm can generate a safe and efficient path for the vehicle to travel through while avoiding obstacles. The next is in the animation field. The RRT algorithm can be used in animation to generate realistic motion for characters and objects. By using the algorithm, animator can create more realistic and natural looking motion. Here are the references. Thank you.